In this next video, we're going to look at what are redox reactions. So, just a quick recap. We know about our oxidation and reduction processes. However, there are 4 different definitions for an oxidation process, 4 different definitions for a reduction process. Okay, so reduction. Reduction is the gain of electrons. That is something that you learnt at GCSE. More importantly, for organic chemistry, it is the gain of hydrogen. So think about converting an alkene into an alkane. And what you'll see in second year is converting a carbonyl into an alcohol. It's also the loss of oxygen. So for example, again in organic chemistry you can do so a process where you take a carboxylic acid and convert it into an aldehyde. There are other processes as well. But today we're going to focus on a decrease or a reduction in oxidation number. The definitions for oxidation are just the absolute opposite. So oxidation is loss of electrons, you know that. Oxidation is the loss of hydrogen. And again we'll see later on in the year where we convert alcohols into aldehydes and ketones. It is the gain of oxygen. So where an aldehyde is converted into carboxylic acid, that's an oxidation process. But today we're going to focus on an increase in oxidation number. So here we have just a little scale where we're going from a high number, a high positive number, all the way down to a high negative number. Now, we just said oxidation is loss of electrons, reduction is gain of electrons. Sometimes it can be difficult to comprehend losing electrons, gaining electrons, and putting that with oxidation numbers. So what we said was that oxidation is an increase in oxidation number. So for example, if you have a substance which is an element, and elements by definition have an oxidation number of 0, and it loses electrons, such as sodium when it reacts, then sodium forms a +1 ion, so its oxidation number would be +1. So therefore, it will be undergo oxidation. Fluorine, on the other hand, starts off at 0, and to form a fluoride, it gains electrons and becomes a F- ion. So in this case, fluorine would undergo reduction because its oxidation number is decreased. Or the way I like to think about it is that the oxidation number has been reduced. Okay, so here's an example. Iron plus chlorine to give iron chloride. Both the iron and the chlorine are in their elemental states. So they're both oxidation number 0. And it ends up that iron is of an oxidation number 3+. And we know this because we know that chlorides have a charge of 1-. So if we've got 3 lots of 1-, that means that chlorines are contributing -3 overall. So to give us a neutral species, a neutral compound, iron must be 3+. So in this case, iron has gone from 0 to +3. It has been oxidized. Chlorine has gone from 0 to -1. It has been reduced. An important aspect about this oxidation numbers is when you're referring to an oxidation number, you must put the sign in front of the number. It's the opposite of a charged species. So if we were to write the charge of an ion, we would say, well, Fe 3+. that would be your, sorry, that is your ion charge. Whereas, and for chloride, it is a 1 minus ion charge. So you do need to work with both sets, both systems, and if you write the number in front of the sign for an oxidation number, you won't get the mark. Okay. Now, a redox reaction is one which involves both oxidation and reduction. Okay, so read or red from reduction, ox from oxidation. Now, a really important set of definitions here are oxidizing agents and reducing agents. The examiners love to ask this question. It might be come up as a multiple choice, it might be just a 1 marker in your exam. What is an oxidizing agent? An oxidizing agent, or an oxidant, is a species which accepts electrons. You don't specify how many electrons, because we don't know. Okay, it accepts electrons. Do not confuse with the electrophile. So in this case, in this reaction above, the species which accepts the electrons was a chlorine. I think it's gone from 0 to minus 1. So oxidation number has. So the chlorine was reduced. Okay. The reducing agents, okay, the substance that causes something to be reduced is the substance that donates electrons. So what we can say here is that metals are always reducing agents, because when metals react, they always lose electrons. Now that's metals starting off in oxidation number 0, starting off as an element. Okay? Right. So, just let's look at a couple of these reactions. Are these redox reactions? Are they not? Okay, so what we can see here is calcium starts off at oxidation number 0. Oxygen, its elemental state, also starts off oxidation number 0. When you have two elements which combine to form a compound, then it has to be a redox reaction because they're made of bonds with each other. So in this case, oxygen, because it's bound to another element, and it's not a peroxide, it's not bound to fluoride, its oxidation number is -2. That means that the oxidation number of calcium is +2, but we know that because it forms 2+ ions because it's a group 2 metal. So in this case, calcium has gone from 0 to +2, been oxidized. Oxygen has gone from 0 to -2, it has been reduced, therefore it's a redox reaction. In this next example, strontium oxide plus water, to give strontium hydroxide. So strontium is now starting off in oxidation number +2 because it's part of a compound, it's not in its elemental state. In the product, it's also oxidation number +2 because it's combined with 2 hydroxide ions. Each hydroxide ion has a charge of -1. Oxygen here has an oxidation number of -2. If we look over here, this oxygen in hydroxide, that also has an oxidation number of -2. This oxygen here in water has an oxidation number of -2. You saw that in the previous video. And hydrogen has got an oxidation number of +1. And over here it's got an oxidation number of +1. So this is not a redox reaction. So not all chemical reactions will be redox reactions. Some will be redox. Some of them won't. In the next video, we're going to look at writing redox equations from half equations. This is a very complicated process, but one which should be okay if you follow the logic and the rules. Okay, thank you for watching.